So, have you ever thought about how a certain chemical reaction can suddenly create a massive foam?
A foam that looked just like toothpaste made for an elephant.
So in this session, we will be investigating this reaction through our laboratory activity entitled the Elephant's Toothpaste.
And here are the objectives for today's experiment. Observe the catalytic decomposition of hydrogen peroxide and identify its reaction products. And also, measure and compare its reaction rate indicators, which are the time to start, peak foam, and its foam height across the 3 trials. Required safety you need to follow. You must wear your personal protective equipment attire or PPE, which contains your goggles, nitrile gloves, lab coat, or apron. And for the girls, you need to tie back your long hair. In terms of hazards, 3% of hydrogen peroxide is an irritant to eyes or skin. The reaction is exothermic, so expect that the container and foam may become warm. So, do not touch the hot glass or plastic. Work over a tray or sink and prepare a bottle of water and eye wash nearby just for in case. Do not inhale yeast dust. Keep the packets closed until it will be used. And lastly, clean spills immediately with water and wash your hands after the activity. As for the materials, we will be using the same materials per group and trials. In chemicals, we need 120 ml of 3% hydrogen peroxide or agua oxigenada, and 12 ml of liquid dish soap that is equivalent to 2.5 teaspoons. Next is a 7-gram or 1 packet of active dry yeast, 4 ml of warm water for yeast activation, also 1 teaspoon of table sugar, and lastly the food coloring for effect. Meanwhile, in apparatus or in lab, we will be using flask and beakers, but we don't have the apparatuses at the moment, so instead, we used an alternative, which are the plastic bottles and the containers. And also, don't forget the ruler that should be in centimeter for measuring the foam. We also need the funnel, steering rod, and tray for containment. For household alternatives, we need plastic soda bottle instead of flask. And also, don't forget the measuring cups and spoons. So that's all for the materials. Now, at the end of this experiment video, we will be working on the data table and answering the analysis questions. So make sure to pay close attention because this will help us understand the activity much better.
Stay tuned!
Now, let's proceed to the experimentation. The procedure will repeat for 3 trials. In Procedure A, prepare yeast activator. First, measure 45 ml water into a 100 ml beaker or container. Next, add 1 teaspoon of sugar and stir. After that, add 7 grams of yeast and then stir gently for 10 seconds. And let it sit for 3 minutes until it will be creamy or foamy. In preparing peroxide or soap mixture, or in Procedure B, first we need to place flask or the bottle on tray and then add 120 ml of 3% hydrogen peroxide. And then add 12 ml of dish soap and stir gently to avoid bubbles. Then lastly, add 2 to 4 drops of food coloring along the flask or the bottle's wall. In next procedure or the Procedure C, which is the start of the reaction, start the timer and then pour the yeast slurry quickly into the flask or the bottle. Use the funnel if needed and then step back. Record the time of the first foam in seconds and also the time to the peak of foam. Then measure the foam's height using the centimeter and the ruler. In the last procedure after the reaction, wait until the foam stops and container cools, and then record the final observations. And lastly, rinse the flask or the bottle and the tray with the water. Repeat the procedures A to D for trial 2 and trial 3. After adding the water into the container, add 1 teaspoon of table sugar and then stir. And the active dry yeast, and don't forget to stir. Set the timer for 3 minutes and wait for the yeast to be slurry. While waiting for the yeast, add the hydrogen peroxide into the bottle, along with the dish soap. Stir them gently so that they won't create bubbles. And add the food coloring to see the effect. And now that the yeast slurry is ready, put it into the bottle with a mixture of hydrogen peroxide and the dish soap. Start the timer, then wait for it to react, and then measure its height by centimeter. Just like what I have said earlier, just repeat the procedure A to D for the last trial. Add the water to the container, then add the table sugar as well as the active dry yeast and then stir gently. While waiting, add hydrogen peroxide and dish soap into the bottle. Once the time is up, add the yeast slurry into the bottle and see the reaction. And then lastly, record the time and its height. So now let's work on the data table for this experiment. For the first trial, we record its foam start by 2.5 seconds while the peak time is 16.74 seconds. Meanwhile, its maximum foam height is 250 centimeters. For the second trial, we got 1.92 seconds in its foam start and 49.2 seconds in its peak time. In its maximum foam height, we got 240 centimeters. For the last trial, the foam starts at 1.15 seconds and reached its peak time by 8.12 seconds. And the measurement we got at its maximum foam height is 250 centimeters. So we are done working on the data table. Now let's proceed to the analysis questions. So the first question is, what evidence from your trials show that a chemical reaction occurred? Identify the physical changes you observed in foam formation, heat, bubbles, and etc. As you can see on the video, the foam and bubbles form quickly when the yeast is added to the mixture of hydrogen peroxide and liquid dish soap. Number 2. Compare the foam start times, peak times, and foam heights across your 3 trials. Were the results consistent? If not, what factors might have caused variation in terms of measurement errors, yeast activity, temperature differences, and etc.? The foam started at different times, grew at different speeds, or reached different heights. But based on the instructions for all the 3 trials, we put in the same amount of the given ingredients. But as we see on the video, the differences of its reaction could be from the measurement errors that we made. In question number 3, the reaction involves the decomposition of hydrogen peroxide. Identify which species is oxidized and which is reduced in this redox reaction. In the reaction, both substances are changed because hydrogen peroxide breaks down into water and oxygen. One part of it loses oxygen, which is the oxidized, and another part gains oxygen, which is the reduced. So in the last question, the yeast contains the enzyme catalase. How does the catalyst affect the reaction rate? Would the decomposition occur without yeast? Based on the experiment, the yeast has catalase, making the reaction happen faster. If without yeast, the experiment reacts slowly, although the hydrogen peroxide will still react but very slowly.
So that will be all for our week 3 laboratory experiment. Thank you!
Okay na to!